will be crushed. Then, through a chemical transformation called the Bayer process, alumina is extracted. This is then roasted in calciners to eliminate all moisture. This is alumina. It is transported by rail to the reduction facility.
Natural ore of aluminium. The rocks get their colour from red iron 3 oxide impurities in the ore. Before aluminium can be obtained, these need to be removed to leave pure aluminium oxide, known as alumina. The Bayer process removes the alumina by a series of chemical reactions. After filtration, a mixture of pure aluminium oxide and water remains.
We put some bauxite, or aluminium oxide, and we heat it up with sodium hydroxide solution, a strong alkali. Now, aluminium oxide is amphoteric. It acts both as an acid and as a base, so it dissolves in the alkali to form a salt, sodium aluminate, but the impurities are not affected. Filter, and the sodium aluminate solution passes through the filter paper, leaving the impurities behind. If we now acidify the filtrate, the sodium aluminate is decomposed and pure aluminium hydroxide is precipitated. This pure white aluminium hydroxide can be filtered off and heated to produce pure alumina, aluminium oxide.
The mixture is heated to 1,200 degrees Celsius, causing all of the water to evaporate, leaving a dry white powder, alumina.
This is one of the 4 rows of electrolysis cells where the electrolysis takes place. The current is about 157,000 amps at 4.5 volts. This is one of the 312 cells. The electrolysis cell consists of a rectangular steel shell lined with heat-resistant brick and then carbon. Each cell is filled with molten cryolite. The aluminium oxide is dissolved in molten cryolite so that it conducts electricity. 18 carbon anodes dip into the electrolyte. During the electrolysis, aluminium ions move to the cathode, gain electrons and become aluminium metal. Oxide ions move to the anode, where each ion loses 2 electrons and the atoms pair up to become oxygen molecules.
To the negative carbon cathode, where they gain electrons to form aluminium atoms. The negative oxide ions are attracted to the positive carbon anode, where they lose electrons to form oxygen gas. Before bonding with the carbon of the anode to produce carbon dioxide gas.
A crust forms on the electrolyte, and this has to be broken to feed in new aluminium oxide. This happens every 3 to 4 minutes. The hoppers on the cells are filled from an overhead ore bucket every 16 hours. The electrolyte is at about 955 degrees Celsius. At this temperature, the carbon anodes gradually burn away in the oxygen from the electrolysis. Eventually, the anodes have to be replaced, and this happens every 28 days or so.
Spent anodes are recovered from the pot with this overhead crane and carried off to be recycled. They clean the aluminum rods, which will then be reused. Here we see the crust formed atop the anode. When the anodes are replaced, the accumulated impurities have to be recovered from the top of the pots. This is accomplished with these pincers. Then a new anode is inserted into the alumina and electrolysis continues.
The remaining carbon is broken off the old anodes, crushed, mixed with new coke and pitch, and pressed into shape. The newly pressed anodes are baked for about 24 hours in gas-heated pits. Steel stubs are fitted onto the baked anodes. The anodes are sprayed with molten aluminium to protect the top and sides. Electrolysis takes place 24 hours a day, 365 days a year. A loss of power of more than a couple of hours would be disastrous, as the electrolyte and the aluminium would solidify.
The electric current breaks the molecular bonds. The heavier aluminum collects at the bottom of the pot.
Liquid aluminium is sucked from the cell into a brick-lined steel crucible. Each cell produces about 50 kilograms of aluminium per hour.
The liquefied aluminum remains at the bottom of the pot. It has to be recovered in this huge crucible with a tube. The tube is dipped into the bottom of the pot and a vacuum system draws the molten aluminum from the crucible. The aluminum is recovered in a short time. Air is vacuumed from the crucible by a flexible pipe held by an operator. The tube is finally withdrawn and the overhead crane dumps another quantity of alumina into the pot. Thus, the aluminum fabrication process continues uninterrupted. The crucibles filled with molten aluminum are transported to the casting house. Their contents are poured into holding furnaces which have a capacity of 60 tons. In these very hot furnaces, the molten aluminum is stored to await casting. Finally, casting begins. The aluminum is either semi-continuously vertically cast, producing ingots, sheets, or billets, or directly cast into semi-finished products. The cooling of aluminum pieces is accelerated by water sprays. The large rectangular ingots, which can weigh up to 25 tons, will head for hot rolling.